I'm going to discuss how to solve radical equations. The procedure I'm going to show you is eventually going to involve squaring or cubing or some analogous step both sides of an equation to eliminate one or more radicals. All right? So let me do some examples to show you what I mean. Suppose you wanted to solve this radical equation. All right? The first thing I would suggest is isolating the radical. So for this equation, you could subtract 4 from both sides. Now look what happens when you square both sides of the equation. You get a form that does not have any radicals. So now you can just solve it the normal way. In this case, I'd subtract 1 from both sides, divide both sides by -3. Okay? And so apparently the answer is -21. It's important to plug candidate solutions into the original equation because sometimes you will possibly get, you will possibly violate the rules of math using your candidate solution. All right. Now this one, the solution is going to work out, but it's still a good idea to plug in your candidate solution to confirm that indeed you didn't make any silly calculation error. All right, so the square root of 64 is 8, so indeed it checks out. Okay, so now we can put the square around it, so the answer is -21. All right, let's do another example. Suppose we wanted to solve this equation. The cube root of the difference 4 minus 2a is equal to -2. For this example, I would recommend cubing both sides. If you cube the left side, you'll get 4 minus 2a. If you cube the right side, you'll get -8. Once again, we arrive at an equivalent equation with no radicals, so we can solve it the normal way. In this example, let's subtract 4 from both sides. And now let's divide both sides by -2, so we get 6. As before, let's plug in our candidate solution to make sure we didn't violate the rules of math. And furthermore, to make sure that we didn't make any silly calculation errors. So the cube root of 4 minus 12, does that equal -2? Does the cube root of -8 equal -2? And indeed it does. So this candidate solution checks out. So the answer is 6. All right. Let's do, how about if I have you do an example now? Try to solve this equation. All right, so pause the video and try to solve that now. All right, so I'll go ahead and solve it myself. The first thing I'm going to do is isolate the radical. So I'm going to subtract 1 from both sides. Now I'm going to square both sides to get an equivalent form that has no radicals. Now I'm going to expand out the squared term and solve the quadratic the normal way. So x squared minus 2x plus 1 equals 15 minus 7x. And I could move everything to the left side and I will get x squared plus 5x minus 14 equals 0. Right? I can now factor the quadratic equation to get x plus 7, that binomial times x minus 2 equals 0. So apparently the candidate solutions are x equals minus 7 and x equal to 2. All right, so as before, I hope you plugged in the candidate solutions into the original equation. So let's plug in the minus 7. So minus 7 equals 1 plus the square root of 15 minus 7 times minus 7. So that gives minus 7 equals 1 plus the square root of 15 plus 49. All right, or let me now subtract 1 from both sides. Minus 8 equals the square root of 64. Okay, or minus 8 equals 8. Lo and behold, look what happened. Okay, we violated the rules of math, and that's why we got garbage. So we have to throw out the minus 7. This is what I was talking about. All right, sometimes you will get incorrect solutions using this procedure. Okay, so hopefully you plugged in the 2, and if you did, I'll tell you that plugging in the 2, you will see that that one does work. So the only answer to this equation is 2. Okay? Now let's close by having you do one more example. Solve this equation. The square root of x plus 5 equals 1 plus the square root of x. So pause the video and try that now, please. All right, I'll go ahead and solve this one. Now, I'm going to square both sides. However, unlike before, I'm not going to immediately eliminate all the radicals. Squaring both sides, if I square the left side, I get x plus 5. If I square the right side, I get 1 plus the square root of x squared, which is 1 plus 2 root x plus x. All right, now let's isolate the radical like we did before. So I have x plus 5 equals 1 plus 2 root x plus x. Let's subtract x and subtract 1 from both sides. So that gives me 4 equals 2 root x. Now let me divide both sides by 2. And now let's square both sides again. And so that will give me 4 equals x. Okay, and as before, as always, when we're solving radical equations, let's plug this into the original equation and see what happens. So I get the square root of 4 plus 5 equals 1 plus the square root of 4. On the left side, the square root of 9 gives 3. On the right side, 1 plus the square root of 4 gives 1 plus 2. And indeed, that checks out. So the answer is 4 for this one.